We have taken a look at solving quadratic equations by factoring. Now, sometimes it is not easy, if not almost impossible, to factor certain quadratic equations. And in situations like these ones, we have another algebraic tool that allows us to solve for the roots or solutions of a quadratic equation. Now in class you would have taken the time to develop the quadratic formula so you can see where it's coming from. For the purpose of this video, we're going to assume that you have seen that demonstration or that mathematical proof of the quadratic formula. Equations in the standard form ax squared plus bx plus c can be used to solve for roots using the quadratic formula, which is x equals negative b plus or minus square root of b squared minus 4ac over 2a. Now let's look at the first example, and for the first few examples I'm going to choose equations that are easy enough to factor so that we can compare between the two methods. Now for x squared plus 4x plus 3, I'm hoping you can see that it factors into x plus 1 and x plus 3. This one was fairly easy to factor, a simple trinomial without too much trouble. And the roots would be x equal negative 1 and negative 3. However, let's practice the use of the quadratic formula for this particular equation. Well, first I want to identify what my a, b, and c coefficients are from standard form. Well, in this case, x squared does not have a coefficient that's visible, so it's 1. b is 4, and c is positive 3. Well, now we have to substitute the values into the quadratic formula, so we have x equals negative 4 plus or minus square root of, well, 4 squared is 16 minus 4 times 1 is 4 times 3 is 12, 4ac, over 2 times a, or 2 times 1, which is 2. So, continuing, we have negative 4 plus or minus, well, let's look at square root of 16 minus 12. Well, 16 minus 12 is 4, and square root of 4 is 2 over 2. And now we can separate into a positive branch and a negative branch, meaning that the positive branch will take into consideration the plus sign between negative 4 and 2. So I have negative 4 plus 2 over 2, or the negative branch is negative 4 minus 2 over 2. I don't want you thinking that a positive branch will always produce positive roots. No, it just relates to the fact that I'm going to take into consideration the positive and the negative between the two terms. So, negative 4 plus 2 is negative 2, divided by 2 is negative 1. And negative 4 minus 2 is negative 6, divided by 2 is negative 3. Now, thinking of the two methods, you can notice that factoring that equation was a lot faster than the quadratic formula. Let's try another one. My a is 1, b is negative 4, and c is negative 5. So, what are the roots? Well, I have negative b, or negative 4, plus or minus square root of, and for this particular case I would like to write it in detail because a lot of you, I notice, make the assumption that when you're squaring a negative number you don't need to use brackets. We do have to use brackets because we want to show that we have negative 4 multiplied by itself, or negative 4 squared, which will in turn give us a positive result, minus 4 times 1 times negative 5, that's another square root, over 2a or over 2. Well, negative 4 gives us positive 4, plus or minus, we have 16 plus 20 is square root of 36, so this right here is 36. Well, what's square root of 36 is 6 over 2. So again, we have two branches, a positive one and a negative one. So 4 plus 6 over 2 equal to 5, or 4 minus 6 over 2, which equals to negative 1. Well, let's see if we can also factor that equation. Well, we notice that by factoring we have x plus 5, sorry, x minus 5, I'm making a mistake as well now, x minus 5 times x plus 1 equal 0. So again, x minus 5 over here, because we have negative 4x, so x minus 5x gives us negative 4x. For that third one, I know it reminds you of some perfect squares, because we have a perfect square to start with, a perfect square to end with. However, that middle term does not verify the perfect square pattern. So for this one, I want you to try on your own to apply the quadratic formula and solve for it. Now, what's special about the quadratic formula? Let's look at page number 2. So the quadratic formula, we said it was x equals negative b plus or minus square root of b squared minus 4ac over 2a. The discriminant is the name given to the expression that appears under the square root sign in the quadratic formula. So discriminant is d equal. So the expression under the quadratic formula. So b squared minus 4ac. Now, the discriminant tells you about the nature of the roots of a quadratic equation. It will quickly tell us the number of real roots. In other words, the number of solutions associated with a quadratic equation. And whenever you are trying to solve a quadratic equation, I would always suggest calculating the discriminant first. Why? Well, we'll see in a second why, but basically if that discriminant is positive or 0, then I know it's worth either trying to factor or trying to go on with the quadratic formula, because the equation will have real roots. However, if the number under this radical or the discriminant is a negative number, I cannot have real roots. We can't square root a negative number, and then the quadratic equation will have no roots. So, when the value of the discriminant is a positive number, we will have two possible roots. Well, let's look at this example and quickly check. Well, if I factor it, I have x plus 1 times x plus 5 equals 0, and the roots are negative 1 and negative 5. Well, what's the discriminant? If we go and calculate the discriminant, it is b squared, or 36, minus 4 times 5, 20. It is 16. So yes, 16 is definitely greater than 0. So remember, when the value of the discriminant is a positive number greater than 0, we have two possible roots. What happens when the discriminant is 0? Well, I can notice from this example that I do have a perfect square, which is x minus 1 squared equal 0. Well, in this case, I only have one root, or one possible solution, which is x equals 1. So, when the discriminant is 0, I only have one possible root. Let's check. Well, b squared is 4, minus 4ac, which is 4. It is definitely 0. Let's check the last one. It says here that when the value of the discriminant is a negative number, I have no roots. Right, let's check. The discriminant is 9 minus 4 times 10 is 40, or it is negative 36. And I'm sure some of you have tried to factor and thought 5 and 2 are factors of 10. However, notice that the middle term is a negative number, while the last one is a positive number. You don't have any real numbers that will allow you to factor this equation. It's not factorable. So remember, let's review quickly. When the discriminant is positive, you have 2 possible roots. When the discriminant is 0, you only have 1 possible root. And when the discriminant is negative, you have no possible roots. Thank you.